Hi guys, it's a guy Olumide, and today we will be talking and solving another one of the most commonly asked tech interview question. It is the find in the insertion index. It's commonly asked by top tech companies that include Amazon, Google, Netflix, Meta, Apple, Microsoft, and other top tech companies. The problem statement states that you are given a sorted array that contains unique value along with an integer target. So inside the problem statement, we are going to be given the array and then another target and an integer target value. So if the array contains the target value, we should return the index. Just like in this case, we can see that the array norms contain the integer 4, so we are going to return the index 2, the index at which that particular value is found in the array. Otherwise, if it is not in the array, we have to return the insertion index. So insertion index is the index where the target would be if it were inserted in order, maintaining the sorted sequence of the array. So it's just like we are dealing with a sorted array. Don't forget, from the problem statement, we are dealing with a sorted array. So in a situation whereby the target is not in the array, like this case now where we have target 6 is not found in the array, we are gonna return the index at which it should be found. So at which it should be found, which should be after 5 and just before 7, because that's where 6 fits in. So one thing you see from this problem statement is that whether or not the target is in the array, we still want to return the index, the true index that it should be, or that it is found. So in case if it is found in the array, we should return the index. If it is not found, we should return the index that it should be in the array. To solve this problem, we can divide it into two cases. The first case is when the target exists in the array. The second case is when the target does not exist in the array. For the first case, when the target exists in the array, we just simply want to return the index whereby we found that target, the position whereby the target is in the array. In a scenario whereby the target is not in the array, we see that the insertion index that we are asked to return is found in the first value that is greater than the target in the array. Like in this scenario now, fine, 6 is not in the array, but the insertion index is the first value that is greater than 6 in the array, which is this position 4. And if we look into it, if we are to insert 6 into this array, we are inserting it into the index 4. So 6, whenever the target is not in the array, the insertion index is the index of the value that is greater than of the first value that is greater than that particular target in the array. Because notice that 7 is greater than 6. Let's say now that target is 6, 7 is greater than 6, 8 is greater than 6, 9 is greater than 6, but the insertion index will be the index of the value, the first value that is greater than that 6, which is right here. Since we don't know if the target exists in the array or not, we are going to be given a random array, and we don't know, we can't actually decipher from the problem statement whether it will be found in the array or whether the target is not going to be found in the array. So we're going to be using a objective that will combine both cases. So we can find for both cases by finding the first value that is greater than or equals to the target. So by doing that, we are going to solve for any cases whether or not it is in the array. Let's take what I'm trying to say in essence is that if we place the condition to be more general, that okay, finding for the first value that is greater than or equals to the target. Don't forget, we are involving two things now, two operations, greater than and equals to a target. So if it is equals to a target, the first value that is equals to the target, we are going to return it, which in this case, for this particular instance, for this particular example, in the first case, we are going to return index 2. Why? Because the position, the element at index 2 is 4, is greater than and equals to the target. You understand? Even though it's not greater than it, it is equals to it. So, and it's therefore it satisfies the condition. Similarly to the second case here, we see that even though the element 7 is not equals to the target 6, but it is greater than it. So we just want to find the first target that is greater than and equals to the target that we are looking for, the first value in the array that is greater than so or equals to the target we are looking for. In this case, 4 is equals to it, and it's the first target that is equal, because right before 4 is 2, and 2 is not greater than, is not equals to it, but 4 is equals to it. So we are going to pick the position 4, which is index 2. We're going to return the index 2. And for the second case here, find 5 is not greater than 6, and it is not equals to 6. So the first value that is greater than or equals to 6 is 7. So we're going to return the position 4. So using this condition now, it's going to work for any cases whether or not the target is in the array. As the array is sorted, we are going to be using binary search, the binary search algorithm, to find that particular index that satisfies this condition. In this binary search now, we are effectively looking for the first targets that satisfy a given condition, and the condition is that the value must be greater than or equals to the target. So the first value that is greater than or equals to the target is what we are using the binary search algorithm to find. So let's visualize it now and see which of the array, we are giving this array as an example. Let's see which of the arrays satisfy the condition. Now we see that the target is 4, alright, and then because the target is 4, 1 does not satisfy this condition, right? 2 does not satisfy this condition because it is still less than 4. But right here, 4 satisfies the condition because it is greater than or equals to 4. It's actually equals to 4, so it satisfies the condition. 5 also satisfies the condition because it is greater than 4, and because the array is sorted, everything to the right is going to satisfy the condition. So similarly, target 6, for target 6, 1, 2, 3, 4, 5 will not satisfy the condition, but 7 satisfy the condition because it is greater than the target, while 8 satisfy the condition. Don't forget the target is that the value must be either greater than or equals to the target. So from 7 upward to 9 satisfy the condition. So one thing we notice is that we have multiple values that satisfy the condition in both array, in both scenarios. So, and that's why we say we wanna return the first value that satisfies the condition. So, and that's the lower bound. That's what we call the lower bound, meaning that fine, during the binary search we might land. Don't forget, if you are with me, if you watch the previous video, I talked about binary search and I used a dictionary as an illustration. You understand? So whereby whenever you want to open to a page in the dictionary, realistically we are just gonna open to the middle of the dictionary, and let's say we fall at M, we're gonna check, okay, we are looking for I probably are looking for the word interest. So, and then when we fall at M, then we just swipe again to the middle. Between A and M, we swipe to a random middle. You understand? So, and that's how we just continue. So that's same thing is gonna apply in this instance now. And let's say that we fall at this particular T right here, so which is probably the middle in this array. So, but because fine, it is true, you understand, because it falls at 5, and 5 is at least greater than 4, even though it's not equals to 4, but the condition says that it must be equals to or greater than 4. Because it is greater than 4, it matches the condition. But we really want the first element or the first value in the array that matches the condition. So we are gonna go for the lower bound. So which means that the first value here that matches the condition is the lower bound, and that's what we are interested in. So you will note that finding the lower bound is is just the same as effectively finding the leftmost value that evaluates true. As you can see in both cases, leftmost value that evaluates true. So what we're gonna be doing, we're gonna be starting with the binary search process now. So don't forget the first step is to define the search space. if you watch my previous video, the one previous to this, I give an introduction to binary search. You can watch it on YouTube, and you will understand. So we have some steps that you take whenever you are using the binary search algorithm. So the first step is to define your search space. The search space is actually the set of possible number that could include our targets in the array. If the target exists in the array, it could be located at any position from 0 to n-1. Don't forget, it is array is 0 indexed, so right from 0 to n-1, it could be located anywhere if that target exists in the array. So, but in a situation whereby it does not exist in the array, probably it is greater than even the maximum number in the array, that is the last number. Definitely it's gonna be the insertion index is gonna be n. I don't think you understand what I'm trying to say there. So right now, the question asks us to find the target and return the index at which the last target is located in the array. But if it is not in the array, we want to return the insertion index, which is the index whereby it is meant to be in the array. But in a situation whereby it is found in the array, fine, we are gonna be choosing or eventually getting an index that ranges between 0 and n-1. But in a situation whereby it is not in the array, definitely it is greater than the maximum number in the array. Just like, let's say that the target we are finding here is 10, whereby the maximum number is 9. So then the insertion index that will be returned is n. It's gonna be n. You understand? So because it goes beyond the n-1, the overall insertion in the array, so it's gonna be n. Now we are going to be defining the midpoint of the binary search. So don't forget, in our previous video we said that it's gonna be left plus right divided by 2, so to get the middle point. So because binary search work by choosing the middle of the array or the database or anything it's trying to work on. So choosing this midpoint, now we see that it's currently pointing at the value 5, and 5 satisfies the condition of being greater than and equals to the target 4. You understand? And because of that, it means that the lower bound is either at this particular midpoint, at this particular position. Why? Because it satisfies the condition. And if you look back here, so the lower bound is a bound, or is at a position that satisfies the condition. So definitely this particular mid value satisfying the condition being greater than or equals to the target means that it is at either at the lower bound, or the lower bound is to the left. So what I'm trying to say is that, okay, fine, we have an array, and then we choose a middle by finding the average of the left and right, so we can fall in the middle of the array, from the two extreme of the array end. So, and getting to the middle position now, it's evaluate true. Definitely we know that the lower bound that we are looking for, which means that the leftmost value that evaluates true, that's what we want to return. So the lower bound is either at that position, or there might be some more value that evaluate true to the left. Imagine now it falls at 5. 5 is right here. So it's either this point is the lower bound, that is the very first value that evaluate true, or there might still be more value to it left. You understand? So because of that, we are going to narrow our search space to the left by placing our right at that particular middle value that evaluate true. So right will be positioned, this right now will be positioned right here, just like you can see below in this visual here. So right will be placed there. Why we place it there exactly is because it satisfies the condition, number one. You understand? And number two is that we don't know, there might be a more lower bound to the left. That is, there might be a value that even satisfies the condition to the left of this particular middle position, which is the right now. So, but we are placing the right exactly on the middle because it also satisfies the condition. So in case if there's no more value, we're just gonna know that this position 5 is the one that satisfies the condition and it is the lower bound. Now after placing our right, after narrowing the search space to the left by shifting our right further to the left, we are gonna evaluate the middle point again, right from using this particular search space. So the middle is gonna fall on this 2, on this particular index 2, and this particular index 1 that corresponds to element 2. You understand? So and right there we see that the middle position does not satisfy the condition that we have laid down. It is not greater than or equals to the target, and therefore we know that everything to its left, including this middle value, does not satisfy the condition. So what we do is that we are going to place our left pointer away from the very first element that it is initially. It's now going to be at middle plus 1 position, meaning that the position next to this middle. While we are placing it, if you remember, we actually place right on the previous, exactly on the previous middle position, not middle minus 1 or middle plus 1, and it's because that middle position evaluate true, so it could be the lower bound that we are finding, so we don't want to ignore it. But because this new middle position is 2 and 2 is less than 4, so it is not even is not greater than or equals to it, so we are quite sure that it is not the target we are looking for, because it is less than it, and it is not the insertion index neither, because insertion index, even if it's not the target, is going to be greater than it. So because of that, we are going to ignore every element to its left, including the middle value itself. So therefore we are going to be setting our left pointer to middle plus 1. So instead of falling right on this middle 2, it's going to be falling on 4 now, and that is why it is falling on 4. So our search space now have been narrowed down to the right, because the left now moved from the first element to around the third element here. So this is our space bar now, so our search space now. So again, we are going to evaluate the middle from here. The middle is going to fall at the very first, it's just 2 items now, and if you say look at their index, 2 plus 3, that is 5. 5 divided by 2 give us 2 if we truncate it. So and because of that, the middle is still falling back at the position 2. So at this position 2 we have 4. We say that 4 satisfies the condition of being greater than or equals to the target, which is 4, and because of that we are gonna set our right pointer to that particular middle position, which is the left position. Don't forget, middle and left position now share the same middle and left pointer now share the same position. So we're gonna set our right pointer there. So you see, at first, even though 5 satisfies the condition, that's why we set our right pointer there. So but now we now see a more lower bound. So that's what I'm trying to talk about. We have now found a more lower bound, which is 4. So right now I've been set to that 4 again, and well, eventually the left and the right pointer are now pointing at the same elements, at the same position, so we can return the position that the element at that position is gonna be our index. Hope you understand. We're gonna return the index at that position. So and that's how to solve that problem. So but another scenario is the situation whereby the target does not exist in the array. Don't forget that we are following along with 2 scenarios. So and we have a common condition that we define for both of them that will work for them. So right now let's deal with that. So consider this array now. We are looking for the target 6, and 6 is not in the array. You understand why? Because we have 5 followed by 7, but we are asked to return the insertion index, that is the index at which is meant to be, even though if it's not in the array. And if we look at it, just like we defined earlier, that it's gonna be the index of the very first value that is greater than 6, and we see that 7 is greater than 6 and the position is 4, the 4th index, and that's what we're going to be returning. So let's walk through that as well. Again, we're going to be dividing our middle position to be in the middle between left and the right. Don't forget, our right will be at the extreme at n. We're going to set our right to n, Why? Because in a situation whereby our target is even greater than every element in the search space, this is the search space now, is the search space is between range 0 to range n-1. But what if the value we are looking for is even greater than the highest number in the array? So that's how we set our right pointer outside the array, that is, we place it at n. So, and now the middle position fall in 5 is still the same way. Calculating left plus right divided by 2 is going to give us the middle position. And then after doing that, we see that when we examine the value at this middle position, it is 5. 5 is less than 6. So that means that our target is toward the right. So we have to narrow the search space to the right by shifting our left pointer to middle position plus 1. We have to ignore the middle position as well, because it is less than, it does not satisfy the condition of being greater than or equals to. It's actually less than the target 6. So that's why we set our left pointer to middle position plus 1, and that's what we have here. Our left pointer is now at this position. So looking into this position now, you will see that at this position we are gonna find the middle again. So we're gonna find the middle point, the middle value. The middle value falls at 8. Between left at 7 and right at 9, the middle position is gonna be 8. And when we look at 8, when we examine it, we see that 8 is greater than or equals to 6. It's actually greater than 6. So it satisfies the condition. So what we do is that we set our right pointer to that middle position. Why? We are not gonna set it away from the middle position. We are going to set it exactly at that middle position because it satisfies the conditions, and it may be the lower bound. We don't know, so we don't want to ignore it. So setting it there now, we are going to examine the middle position again. You see that it's just 2 numbers now, so the middle position is going to fall to the left hand side, and because of that, we are going to examine the value at this left hand side now. You see that the value also is greater than or equals to the target, because the value is 7. So 7 is greater than or equals to the target. So we are also going to set our right pointer at that value. Why? Because it is now the lower, because it is lower to the previous lower now. So it is the new lower bound. So setting our right there now. Fortunately, the left and the right pointer is now pointing at 7. So we need to exit the loop now. So by exiting the loop, we're going to return the value at the point whereby they meet, which is just the value at the left pointer, because the left pointer and the right pointer are pointing at the same value, because they met, and because of that we just have to return one of the 2 pointed, because actually they are pointing at the same value. So therefore, let's summarize the logic. Let's just summarize the logic. So we have 2 cases now. The first case is when the middle point value, when we evaluate the middle from left plus right divided by 2, we evaluate the middle. So if it is greater than or equals to target, that indicates that the lower bound is either at that middle point itself or to its left. So in that case, we are going to narrow the search space toward the left, while ensuring that the middle point is included, because that middle point itself satisfies the condition. So it might even be the lower bound that we are looking for. Imagine a situation whereby 4 is not there at all. All we have is just 1, 2, and 5, and 7, and 8, and 9. You will see that that middle is the only is the very first value that satisfies the condition. So it's our lower bound, and we have to return it. So that's why we need to include it. That's the main reason why we are setting our right pointer exactly at that middle point, so that it will include it in the search space. So, and that's what happened here. So, but in a situation whereby the middle pointer is less than the target, that indicates that the lower bound is somewhere to the right, and it does not include the middle. Why? Because the middle pointer is even less than it. So we are looking for a value that satisfies the condition of being greater than or equals to the target. So because of that, we are going to set our left pointer, we are going to shift it to the right by setting our left pointer to middle plus 1. So it's going to ignore everything to the left of the middle position, including the middle itself. Why? Because it doesn't satisfy the condition. So that therefore narrowing the search space to the right. That way we have narrowed the search space to the right, and that's it. So we just keep doing that. What we do next now from this step is that we found the middle position again, understand, and the middle position is gonna be at 2. Imagine now when we have our search space narrowed down to 1 2 1 2 4 5, so it's gonna be at 2, and then we're gonna look again, is 2 greater than equals to the target? Does it satisfy the condition? If it does not, we're gonna shift our left pointer again to middle plus 1 and until they meet at 4, and then we return at the position whereby they meet. So let's go into the code implementation. I hope you understand how this logic works. We're gonna be implementing it in the code implementation. So let's walk through the code implementation. We're gonna be defining our function as the find insertion index, and we are gonna be collecting the array nums, which is going to be a list of integer. So we're also gonna be collecting the targets, so which is going to be an integer. So and the return is an integer insertion index. So let's define our array, our parameters, and here it is. Alright, let's carry on. We have our nums and we have our targets, so we can even call it right here. So print, we can call it, so we just pass in those parameters, nums and target. So and now we are right here. Let's define our boundary, the boundary of the space, or of the slash space. So and we're gonna define it as 0, length of nums. So don't forget, the left pointer will be situated at 0, while the right pointer is gonna be situated at length n. So it's not actually situated at the last element. Last element in the array nums will be n minus 1, or nums length of nums minus 1. But we want to situate it right outside the O search index because of the situation whereby the target we are trying to look for is even beyond the maximum number in the array. So that way now the index will be n, meaning that the index is outside of the range. So alright, so while the left is less than right, so we are using while left is less than right because as soon as left becomes right, as soon as they both point at the same position in the array, we want to exit the loop, because at that point they are now referencing the same index, and that's what we need. We just need to return one of them. That's the insertion index we are looking for. So let's evaluate our middle position now, and middle position will be left plus right modulus 2. Sorry, it's not modulus, it's quotient. So that is gonna give us the floor division. It's gonna truncate the decimal away from it, or any fraction. So while we have this defined now, we want to say if nums of mid, so we want to examine the particular element at that middle position. So depending on it, so if it is greater than or equals to the target, so if it satisfies the condition, guess it. Okay, we are gonna be setting our right pointer right at that particular position, so that we could find so we can find the lower bound to the left, to the further left, while including that middle position. So right equals to mid. So but in a situation whereby it is not greater than the target and it is not equal to the target, definitely it's going to be less than the target. And in a situation like that, we want to set our left pointer to mid plus 1. So that's all, and then we can return left, because we'll be assured that by the time the while loop is exited, by the time we exit the while loop, they are going to be equal. So it doesn't matter whether we are returning right or left, so they are going to be exactly the same. So let's run this function now. So as you can see, 2 is being returned. So 2 is actually being returned here. This is it right here, and we solved the problem and we got it correctly. So alright, take care, and I hope you understand this. Don't forget to like, comment and share, and subscribe to our channel, and follow us on our group for more interesting solutions like this. Thank you.